Today we're going to be using the distributive property and using that to factor by grouping, which is a new concept that I know I have not taught this year yet. So here we go. This first example is in example 1. This is something that they have factored a little bit differently, but all essentially they're trying to do is to factor this 12m p plus 80m squared. And so what we've done in class is just found the GCF of each of these, which is what they're doing in this little breakdown here, except they're breaking it down a little bit further than we have, but the same answer is being found down here when they found the GCF, which is 4m, which is what they ended up finding through that process. But what we're really going to be focusing on today is this factoring by grouping. And when we look at this, in order to factor by grouping, there are some key characteristics that have to be present. So what needs to be present is, so we will know that a polynomial is factorable. A polynomial can be factored by grouping only if all of the following conditions exist. So condition 1, there are more than 4 terms. There are 4 or more terms, okay? The second is that the terms have common factors that can be grouped together. And the third is that there are 2 common factors that are identical or additive inverses of each other, which we'll look at a little bit later. So let's go ahead and do some examples together. I think it'll be most helpful to just look at some examples. So on the back of this page, you're going to notice that some of them, those characteristics don't apply. So this one only has 2 terms. So this one's just going to be a factor with a GCF. So all we would do is find GCF and factor it out. So here we would have 24 being the GCF. And then when we divide this by 24 and this by 24, we're going to be left with x plus 2y. And then that is our fully factored polynomial. Again, this one this one has 3 terms, so we can't factor by grouping, but we can find a GCF. So what we're going to do here is our GCF looks like it's going to be a 6. So I can divide, so if I have a 6, and then I can also take out 1p. So if I divide this by 6p, this by 6, oh, I'm wrong. Hold on. All that can be taken out there is actually just a p. That was my bad. So all that can be, so if I factor out a p, I'm left with 30 mp plus m squared minus 6, okay? So again, on a lot of these, you're just going to have to find the GCF, and that's if there are 3 terms or less. And so what we're going to be focusing on, though, are terms that have 4 or more terms. So those are going to be towards the bottom, starting with problems, looks like problem 13. So like 13 through 18, those are going to be the ones that have 4 or more terms. So we're going to be able to factor by grouping. So if you first looked at these, I know some of my other classes said that they would have just written prime. They would have said these are not factorable. There's no common factor that I can pull out. There's nothing that I can multiply to get the 3rd term and then add to get the 2nd term. But that's where factoring by grouping comes in handy. So what we're going to be trying to do is to find terms within the polynomial that have two terms or more terms that we can pair together. So I'm going to go back to this little example here. So we have ax plus bx plus ay plus by. So in all, I wouldn't be able to factor a GCF out of these four terms, but what I can do is I can group them. So if I group these two together, these now have a common factor of x, and if I group these together, I get a common factor of y. So when I factor these out, if I factor out an x, I'm left with a plus b. And on this one, if I factor out a positive y, I'm left with a plus b. So if you also notice in this one, we could have paired these two together, this ax plus ay, and got a common factor of a. And then we could have paired bx plus by and then had a common factor of a and a common factor of b, and that would have worked as well, but this way works fine as well. So once I factor out, so I went from having four terms, so here's my four terms. Now I only have two terms. And between these two terms, I see a GCF. And what that GCF is a plus b. So just like we did at the beginning when we factored out a common factor, we now have a common factor between these two terms, which is a plus b. So if I divide this by a plus b, and if I divide this by a plus b, I am just left with x plus y. So then my two factors of this polynomial become a plus b, which was on the inside of both parentheses here, and then what was left when we took out that GCF, x plus y. And I'm going to just show you that real quick, that this works, because a times x is ax, a times y is ay, b times x is bx, and b times y is by. So if you notice here, when I refoil it to check my work, this right here that I'm boxing is the same as what I'm highlighting here, ax plus, and it, again, the terms are out of order, but they are all present. So again, let's go ahead and look at an example. So we have to put them in pairs where a common factor can be taken out of it. So let's go back down to our problem. I'm going to do problem 16. Problem 16. So if I look at the whole thing, there are four or more terms. And if I look at these factors and those, I see that there's a common factor in this one, and that common factor is going to be 3x. And when I divide this by 3x, I'm left with 4a. And if I divide this by 3x, I'm left with a positive z. So then my common factor over here I see is a y. So my y, and what I need to remember is that it's a plus y, a positive y. And when I divide that first term by y, I'm left with 4a. And if I divide the second term by y, I'm left with a positive z. So if we notice again that this, so now we went from, at the top we had four terms, we now have two terms, and we have a GCF between the two terms, and it's this 4a plus z. So when I divide out, so remember when we factor, when we take out a common factor, that common factor goes to the front of the problem. So we now have 4a plus z as our one that we factored out. And then once we divide both of those terms by 4a plus z, and 4a plus z, our terms that are left are 3x plus y. So that went away, and we are left with 3x, which we put here, and what plus y, which we put there. So what I'm going to do is show you that this could have also been written another way. So in this example, I also see that 12ax plus 4ay. So I'm looking at this first problem. I noticed that these two terms have a common factor, 12ax plus 4ay, but 3xz plus yz also have a common factor, like that we could factor out. So if this became our first term and this became our second term, we now have, if our first pair, sorry, not our first factor. So what I'm going to do is in this example here, when I use this as my pair, I can factor out a 4a, and what's left is 3x plus y. And then over here, what I'm left with when I take out my common factor, I get a plus z. And what's left when I divide this by z and that by z, I get a 3x plus y. So again, this worked as well because in my two terms, I have, so in my two-term problem, this is my two terms, my GCF is highlighted in green, so I'm left with when I divide both sides by 3x plus y and 3x plus y, that comes to the front because I factored it out, 3x plus y, I would just write it once, and then what's left is this 4a, which I put in the first, and then plus z. And if you notice, hopefully you notice, that, let me pick a different color, that here, 3x plus y and 3x plus y, 4a plus z, and 4a plus z. So as long as your pairs have a common factor, your problem will work. So you could do it with these pairs or with these pairs. So both ways will work. But just pick one. Okay. Let's go ahead and do problem 15. So I always like so I'm going to look at this. So if I have this as term 1, term 2, term 3, and term 4, if term 1 and term 2 can be paired, I always just put them together. If 3 and 4 can be paired, I put them together so I don't have to rewrite my problem like I did on that last example. But sometimes it is going to be necessary to rearrange the two problems. And so in this case, 1 and 2 and 3 and 4 do work together. So I'm going to, factor out. In this first one, my common factor is 4m. And then when I divide by a 4m, what I'm left with is m plus, divide this by 4m, I'm going to say an m plus p, because the 4m and the 4m left with just 1. And then over here, I'm going to say plus. I see that these both have a 3, and they both have a p. So when I divide this by 3p, I'm left with m. And I divide this by 3p, I'm left with just 1p. P to the first, sorry. And so if I notice, I'm on the right track because this here and this here, my two terms, now have a common factor of m plus p. So when I divide that out, so if I divide this by m plus p and divide this by m plus p, I'm left with 4m plus 3p. And again, I can show that this worked because 4 times m times 4m is 4m squared, which is my first term. M times 3p is plus 3mp. So again, I don't see it in my second, but it is my third. Plus 4mp, which is my second, and then plus 3p squared, which is my fourth. So I ended just as I started with this being my two factors, m plus p and 4m plus 3p. All right, what I'm going to do is go on over to number 14, because this one is an example where 1 and 2, so let me just go ahead. If this was factor 1, this is factor 2, or sorry, term 2, term 3, and term 4. 1 and 2 have a common factor. 1 and 2 have a common factor of 2y, but 3 and 4 do not have a common factor. So I'm going to try to see if there are any other pairs, and I notice when I look here that 1 and 3 have a common factor of 3y, and 2 and 4 have a common factor of -2. So that's what I'm gonna rewrite my problem so that it's in that order. So I'm gonna say 6y squared plus 3y minus 4y minus 2. So this is gonna help me just keep my problem straight. So now my first group is 6y squared plus 3y, which I know my common factor is 3y, which when factored out, if I divide this by 3y, I'm left with 2y. If I divide this by 3y, I'm just left with 1. In this second group, it's a little trickier because we need to make sure that we recognize any negative signs. So we notice that my common factor here is actually a -2. So when I take out a -2, I'm going to be left with a 2y plus 1. So the goal in doing this is making sure that the parentheses are the same. So now I can now divide both of these sides by 2y plus 1, both of these terms, which will take my problem to 2y plus 1 as my first factor. That goes away and that goes away, and what I'm left with is 3y minus 2. So that's where it's important that we make sure we keep our signs straight. And this is the first example of where that would be an issue. Another one that is going to possibly run into some issues is down here at number 17. So number 17 here, my term 1, 2, 3, I'm keeping my signs, so 1, 2, 3, and 4. So if we notice that I can make a group of 1 and 2 and 3 and 4 here. So when I factor out a GCF, or a common factor of 12a squared plus 3a, my (3a) is going to be my common factor, and then what's going to be left is 4a plus 1. And then again, like that last problem, you're going to have to recognize that the common factor is -2, and what's going to be left is 4a plus 1. So again, making sure to pull the negative sign out. And we have a good sign, we have a green light, so we have these that are the same, so we can factor that out as our first one. And then what's left is going to be 3a minus 2. And that is our two factors. So I'm going to make sure we go over this last one. The bell just rang, so I'm going to have students coming. So I'm going to look at one like this. So there are two ways to look at this. You could think of it as, I could use these as my two groups, except I would have to see that my common factor is actually just 1. But the problem there is that people forget about the 1. So I'm going to show you another way to write this one so that it's so that my terms are in the correct order. So 1, 2, 3, and 4. So I see a common factor there, and I see a common factor between 1 and 3. So I'm going to say x squared plus x plus 2x plus 2. So then that is more doable. So we have our group, and we have our group, and that's from there. Okay, I'm going to do one more example. Again, looking at number 18. Looking at number 18, recognizing that we're going to have to rearrange this for a second. So if I have terms 1, 2, 3, and 4. So again, 3 and 4 have nothing in common. So we're going to have to pair 1 and 3 and 3 and 4, 2 and 4. So xa plus x and then plus ya plus y in order to be able to see a common factor between the two. So again, not all on this page you'll use factoring by grouping. A lot of them you're just going to find a GCF like the 2 problems that I did at the top.